Now we are going into the third example of the applications of completing the square. The third example, you are being given as a function is 2x squared plus 12x minus 1. So we need to complete the square, and this is a completing the square. Since this is a 2, therefore this is under the case of a is not equals to 1. Therefore we need to factorize out. So when I take out the 2, this 12 must be divided by 2. So this 2 is out. Therefore, this 12 divided by 2, this negative 1 we don't disturb, it's remain there. So 12 divided by 2 is actually 6. Therefore, we got this question. Now, we see the coefficient of x squared is 1. Therefore, we can apply the bracket square method. So bracket square minus bracket square method. So therefore, here is x, so this is x. Here is plus, therefore here is plus. Here is 6, 6 divided by 2. Every time this value must divide by 2, you get 3. So you got x plus 3 power 2, then this value is always minus because the concept is what? Bracket square minus bracket square. So this is always minus, therefore here is 3, therefore here is 3. Then you expand this 3, so negative 3 square is how much? Negative 3 square is actually 9. So that means 2 times with 9 is actually negative 18. So the 2 times with x plus 3 power 2 minus 18, then here go minus 1, so this is minus 1. So now we have actually completed the square. The answer will be y equals to 2x plus 3 power 2 minus 90. Now we're going to use the completing the square to sketch the graph under the section B. Now let's sketch the graph. Now when I want to sketch this graph, section B, when I want to sketch this graph, the first thing I need to look at there is x equals to x plus 3 inside the bracket is equals to 0. So I got x plus 3 equals 0, so I got x equals to negative 3. So x equals to negative 3 is somewhere here. So this is x equals to negative 3. Then we got the y value equals to negative 19, so this value is negative 19. So this is y equals to negative 19. So we got here negative 19. Then, so we have done this, So the 2x squared, 2 is no problem because it's only the signs, therefore the shape is still the same. So we're looking at x squared graph, so we're going to draw the x squared graph is here. Like that. When it turns back, we need to know what is the y-intercept, and x equals to 0. So when x equals to 0, you see here the equation here. When x equals to 0, 2 times 0, 0, 0 plus 12 times 0 is what? Negative 1. So when x equals to 0, you get the value is negative 1. So it cuts at negative 1. So somewhere here, then the graph goes like that. So this value is negative 1. Now we have the graph is actually intercept the x-axis as a 2 points. Okay, x-axis as a 2 points. Then one is here. Okay, one is here and one is here. So to find these two values, then I must make it y equals to 0. So I got 0 equals to 2x squared plus 12x minus 1. And since I cannot factorize, so I use a calculator to solve this problem, or we are using negative b plus minus root b squared minus 4ac divided by 2a. Use that formula to calculate what is the value of x. So x equals to 0.0822. So we take 0.08. So this value will be negative 0.08. And this value will be negative 6.08. So I'll take here this value is negative 6.08. So now this is the quadratic graph for the beam. Now from this graph, we need to find three things here. What is the symmetry line? Symmetry line is here. This is a symmetry line. So that can be obtained from this part, which is make it 0 in the bracket. So it is actually equals to negative 3. So the symmetry line is x equals to 3. Negative 3. And to find the maximum or minimum, since the coefficient of the x squared here is 2, therefore this is a positive value, therefore this is a minimum graph. So this will be the minimum value. So the y equals to negative 19 is a minimum value. So the answer, it is a y minimum. So y minimum. is actually equals to negative 19. And what is the turning point? Turning point is a combination of both of them. So combination of both of them is x is what? Negative 3 and y is negative 19. So this is what we call the turning point. Sometimes it's called as a inflection, this is called as a stationary point. Now we are moving on to the section D. Okay, if you look at section D, this is the graph that we need to draw. Now when you want to draw this graph, so first you need to see how the other graph look like. Okay, the other graph will be looking like this. Okay, I will give you the graph, how the quadratic graph. So the quadratic graph will be looking like this. So we need to remain anything above the 0.1. So I'm going to remain this. This is actually 0.08. So I'm going to remain this part. Okay, we remain. And we also remain at the 6 this side. So we remain here. Okay, we remain at this part. Okay, we make it slightly longer. Okay. So this is, let's say, negative 6.08. So this part is been remain. Okay, this part the graph is remain. And here the graph is been in between this one and turning point negative 3 and negative 19. We reflect them. So when I reflect them, so the graph will be at negative 3, and this will be something like that. Comes back, and this is value 1, and this value is 19. So see, here is negative 19, now become 19, and it's happened at negative 3. Okay, so we got the graph. Now this graph we need to sketch according to the range which has been given to us. Okay, we're going to draw this graph, and this graph starting from 0. That means 0 means the graph starts from here. Okay, that means we don't need to draw this side. So that means 0, when x 0 is you get 1. So when you put 0, you get 1. Then when you put x equals to negative 10, on the domain is negative 10. So we put substitute negative 10, 2 times negative 10 square plus 12 times negative 10 minus 1. So you get 200 here, and this is 120 minus 120 minus 1. So we'll be getting about 79. So when x equals to negative 10, we got 79. Now we need to draw the graph. So this is actually somewhere 3. Okay, this is the turning point. This will be 19. So the graph comes like that. So this is 19. And this graph came back to the 0 at here. Okay, came back to 0 at the point negative 6.08. It came back. So it came back here. Okay, it came back here. So it came back. Then the graph goes back. So the graph will go back like that. And this value is about negative 10. And when it's negative 10, it's 79. So this value will be coming here. So this value will be 79. So end of the day, you will be getting the graph will be something like this. So that means you're sketching in between 0 to negative 10. So this value is 79. Okay, the graph is only cuts off at 1. So this is the graph you need to get. So now you need to find the range, and this is included because 0 is included. So this is included, and this coordinate also included. So the maximum value of the y is 79, and the minimum value is 0. So this is where the graph found, and this will be the range. So the range is actually the y. Okay, the y is in between. So the maximum value is 79, the minimum value is 0, and that also included. So the range is between 0 to 79 based on the domain of negative 10 to 0. So now we have completed these applications of completing the square.